Assalamu alaikum, dear students of second year class. And today I am going to discuss the remaining part of the alcohol chapter. In my last lecture, I have explained what is the alcohol, how do you write the name of alcohol, and or a nomenclature of alcohol, and the preparation of alcohol. In this lecture, remaining preparation of alcohol, I am going to discuss. I have discussed the lab preparation of alcohol. Now I am going to tell you about the industrial preparation of ethanol and the methanol. What is this? Example, this is the industrial preparation of ethanol. How do I explain this industrial preparation? Basically, industrial preparation of ethanol is based on the fermentation process. What is the fermentation process? It is a biochemical process in which what happened, a small microorganism produce enzymes. That enzymes converts glucose, fructose, basically glucose, into the ethanol. So you can say fermentation is a biochemical process in which enzymes are converting the sugar glucose into the ethyl alcohol. Two types of fermentation takes place. For example, first fermentation is with the help of the molasses. What is the molasses? Molasses is basically the you can say molasses is a residue which is left after the crystallization of the sugarcane juice. When you can say when you have to crystallize the sugarcane juice, it is dark and viscous liquid. Due to this crystallization, a residue is left behind. This residue is basically called as the molasses. It contains the 60% sugar glucose in it, so we can use it as a base for the fermentation process. And this molasses, when we have to use, what happened? Following reaction takes place in which the enzymes secrete enzymes which are present in the yeast converts the sugar of the molasses into the ethyl alcohol. What are the reactions? C12H22O11 plus water, that is converted into the glucose and fructose, and this glucose further in the presence of yeast, yeast which excrete the enzyme, secretes enzymes, give rise to the ethyl alcohol, right? Next is the another fermentation process. This is also like the molasses. Now we are going to use the starch instead of the molasses. It also contains the glucose and the fructose. First of all, yeast is added to maltose converted into the glucose. Which enzyme converts the maltose into the glucose? Maltase. And next enzyme, zymase, convert the glucose into the ethanol. So you can say yeast basically in the fermentation of the starch, secretes two types of the enzyme. One enzyme is called the maltase and another enzyme is called the zymase. So what is the function of maltase enzyme? That is converting the maltose into the glucose. And second enzyme, that is called as the zymase, which is also secretes by the microorganism yeast, convert the glucose into further ethanol. Look at this reaction. C12H22O11 plus water, so it converts the glucose, and glucose further converted into the ethyl alcohol plus carbon dioxide. So on the industrial level, with the help of the fermentation, by using molasses and by using the starch which contains the fructose, glucose, convert it into the ethyl alcohol or ethanol. Second is, one thing is very important, the alcohol obtained from the molasses or obtained from the starch by the fermentation process is only 12 to 14% pure. So that is called as the rectified separate. So the rectified separate, it's distilled again and again, washed first of all, then distilled again and again, and then we have to obtain the 95% alcohol in the purest form, in the 95% form. This alcohol is called as the rectified separate or commercial alcohol. Or this alcohol is basically the alcohol, you can say, I am going to say something wrong. I think the fractional distillation of the alcohol, which is obtained by the fermentation of the molasses and by the fermentation of the starch, is only 15 to 18% pure. And this one is called as the rectified separate. And this rectified separate is 90 to 95% pure. Right, and this is called as the rectified separate. And rectified separate is further used for commercially used, and that is called as the it's also called as the commercial alcohol. Sometimes if the 10% methanol or a pyridine or any other chemical is added to ethanol, it's called as the denaturing of the ethanol. And this is called as not used for the drinking purposes, and it is called the denaturing of the alcohol. Second is the methanol. Industrial preparation of methanol, first of all, in the past it was extracted from the wood, so it is also called as the wood separate. But nowadays this is prepared. Methanol is prepared by the catalytic reduction of the carbon monoxide. Carbon monoxide in the presence of the chromium oxide and zinc oxide that are used as a catalyst. In the presence, a pressure is applied in the reaction chamber. After this reaction, the vapors of methanol is produced, which are condensed and converted into the methanol. So nowadays, methanol on the industrial level, we have to obtain by the reduction of carbon monoxide in the presence of particular catalyst, which give us the combination of the water gas, carbon monoxide plus hydrogen, that give rise to the methanol on further reaction. Next, this is the two industrial preparations: industrial preparation of alcohol, ethanol, and industrial preparation of methanol, which was left in my last lecture. Now I am going to start the reactions of the alcohol. Two things are very important. If you look at the structure of ROH, right, CH3, CH2OH, ethyl alcohol, methyl alcohol. So you can say there is a two type of reaction can take place. If the bond is broken between the CO bond, right? For example, you can say the bond break at this place. This is the CH3OH. OH is getting separate in this case, and in the center this bond is. Another one are the reactions in which, for example, CH3, CH2OH, the bond is breaking between the OH, right? So first of all, I am going to discuss the reaction in which CO bond break. For example, how do I explain this breaking of the bond? For example, look at this CH3, CH2OH. This is called as the ethyl alcohol. In the presence of ACl and the heat, converted into the ethyl chloride. Look at this. Whole OH is replaced with a Cl. When I was discussing in the alkyl halide chapter, I had told you about this nucleophilic substitution reaction. I have told you that the one nucleophile is replaced with another nucleophile. So the reaction in which CO bond break, it means OH is here a nucleophile, and when it reacts with another nucleophile, just like a Cl is also another nucleophile, then OH is replaced, completely replaced or substituted with the Cl, another nucleophile. So you can say this is the nucleophilic substitution reaction in which CO bond breaks, whole OH bond from this side is replaced, OH whole is replaced with the Cl, right? So in this case, in the breaking of the CO bond, one nucleophile OH is replaced by the Cl. Very simple reaction. In the presence of heat, OH is replaced by the Cl and the alkyl halide is formed. This is for the primary alcohol and this is for the secondary alcohol. Primary alcohol converted into the primary alkyl halide and secondary alcohol is converted into the tertiary alcohol is converted into the tertiary alkyl. I have mentioned here SN2 and the SN1 reactions, right? So this is basically a nucleophilic substitution reaction which follows the SN2 and the SN1 reaction. Next reaction, if you have to change any other, here I have used ACl. If you use SOCl2, that same reaction takes place. CO bond is breaking, nucleophile OH is replaced by the Cl of SO and the sulfur dioxide gas is evaporated. And the formation of ethyl chloride takes place. This is another example of CO bond breaking. First example, you have used ACl. Here you have used SOCl2 as a reagent and replaced the OH with a Cl. Any reagent can be used. Third one reaction is also one of the reaction is left. If you have to react your primary alcohol with the HNH2, then the same reaction takes place. OH here, OH replaced by the, if I am using here for example ammonia NH3, then what happened? OH is replaced with the NH2. Ethyl amide is formed. So in all these reactions which I have explained, number 1 with the ACl, number 2 with the SOCl2, number 3 with the NH3, OH is completely, CO bond is breaking from here and OH is completely substituted with a chlorine or amide. Now go to the next reaction. The following are the reactions in which OH bond breaks. For example, CH3, CH2, OH. Hydrogen from this bond takes place. Which are these reactions? When the reaction, for example, if organic compound gives the proton, then we will call it acid. So you can say alcohol shows the acidic behavior. Why it shows the acidic behavior? Because polarity develop here. Because the oxygen is more electronegativity, it withdraws the electron towards itself and this bond becomes weak and this bond is going to be weak and breaking. So you can say alcohol is showing little bit acidic behavior. How it's showing little bit acidic behavior? By giving its proton, by developing the polarity and by giving the proton. So when you have to react with the sodium, what happened? The sodium when reacts with it, O negative, it gives the proton and the O negative salt and water is formed. Here O negative, when it gives the proton, CH3, CH2O negative form which reacts with the electropositive metal just like a sodium, Na+. This is the one of example in which alcohol shows the acidic behavior by giving the proton and the electropositive metal make a place here with the ethyl alcohol. Another example you can show, for another example is the esterification. What happened? This is the ethyl alcohol, this is the acetic acid. For example, here OH, we draw the hydrogen and other way, this OH bond break, water is formed, and CH3 CH2 CH3 C double bond O negative, and this CH3 O CH2 CH3 negative take its place, and ester is formed. Another example is also here, which you have done in the Grignard region. Ethyl alcohol, when reacts with the methyl magnesium iodide, methyl abstract the proton from the ethyl alcohol, right, and forms a CH4, which we have done in the reactions of the Grignard region. So these are the three examples in which the alcohol shows the acidic behavior by giving it the proton. Reaction with the sodium, reaction of the ethyl alcohol with acetic acid, and reaction of the ethyl alcohol with the Grignard region. In these three reactions, alcohol behaves just like an acid and gives its proton. These are the two reactions in which we have explained. In first case, this CO bond OH is totally substituted, and second reaction in which OH bond takes place and reactions followed. Next are the oxidation reactions of alcohols. Basically, alcohol easily oxidized. How is it oxidation takes place? If the primary alcohol reacts with the oxidizing agent, you can use the potassium dichromate in the presence of acid. Simplest, there are all other reagents are mentioned here, but I am going to explain simple oxidizing agent, that is the potassium dichromate. It releases atomic oxygen, which oxygen adds into the primary alcohol. Very simple way. There are two types of the oxidation. Direct, when you are going to react with your reagent with the molecular oxygen O2. No. Another method is with the oxidizing agent is used, just like a potassium dichromate here, that release the atomic oxygen. This atomic oxygen adds to primary alcohol. When it add to primary alcohol, this primary alcohol or ethanol is converted into the ethanol, or we can say aldehyde, with the water. So alcohol is easily undergo the oxidation reaction. I have already told, addition of oxygen is called as the oxidation. Here oxygen comes from the oxidizing agent, and that is potassium dichromate, which releases the atomic oxygen. This atomic oxygen adds to your primary alcohol. There are three types of alcohol: primary, secondary, and tertiary alcohol. If the oxygen add to the primary alcohol, it gives rise to the aldehyde. If there is a secondary alcohol, just like 2-propanol, you know what is the secondary alcohol? The carbon attached with the functional group, further attached with the 2 alkyl group or 2 carbon atom, is called the secondary alcohol. If the alcohol or a functional group carbon attached with the functional group attached to the further 3 alkyl groups, that is called as the tertiary alcohols. So here I have written the secondary alcohol or a 2-propanol, right, and the functional group attached with the middle one carbon, which is further attached with the 2 carbon, that is called the secondary alcohol. When it reacts with the potassium dichromate in the presence of sulfuric acid, what happened? Now another way, potassium dichromate release the atomic oxygen, which adds in the secondary alcohol, and secondary alcohol is converted into the ketone. Here is written propanol, it means ketone. So it's very easy to understand. If the primary alcohol undergo the oxidation, it gives rise to the aldehyde. If the secondary alcohol undergoes the oxidation in the presence of oxidizing agent, it gives rise to the ketone. Now third one is the tertiary alcohol. It doesn't undergo the oxidation reaction, and instead of oxidation it undergoes the elimination reaction due to the three bulky groups which repels the oxidation, restricts the oxidation, and instead of the oxidation it forms the elimination reaction. You know, alkene is formed in the elimination reaction, which we have discussed in the elimination reaction. So this is the alcohol. Next is the dehydration. What is the dehydration? Dehydration of alcohol. Dehydration means removal of the water. In the chapter 8 alkene, we have detailed discuss about the reaction of alkene. In the reaction of alkene, right now I'm going to tell you dehydration is the reverse. The dehydration, removal of the water. You can use any strong acid. Instead of acid, you can use any dehydrating agent. Dehydrating agent is calcium oxide, which absorbs the water. Right here, when you have to react the primary alcohol in the presence of concentrated sulfuric acid, water is removed and alkene is formed. Water is removed and the alkene is formed. This is the very easy way to describe the dehydration. Dehydration, if you are going to do the dehydration in the case of the primary, secondary and tertiary, the conditions are going to be changed. Tertiary alcohol is easily dehydrated in the mild condition, in less concentrated sulfuric acid and the less temperature, right? And secondary alcohol also needs the less and also needs the mild condition, and the primary needs the more condition and concentrated sulfuric acid and the high temperature of 180 degree for the dehydration, for the removal of the water, and convert it into the alkene, right? Why is it happened? Tertiary alcohol is converted. Tertiary alcohol, when the removal of water takes place, it forms the carbocation. Tertiary carbocation, that is more stabilized than secondary, and secondary is more stabilized than the primary. So dehydration is basically the removal of the water and it converted into the alkene. This hydrogen and OH removed as a water, and this bond is shipped here and forms the alkene. Primary alcohol needs the concentrated sulfuric acid, 180 temperature. Secondary alcohol needs the 60% sulfuric acid concentration, and temperature needs the 120, I think, or if there is a tertiary, it needs only the 85 temperature and the low concentration of the sulfuric acid. Why is it happen? I have already told you, because the tertiary carbocation, which is when the water is removed, the carbocation is formed. Tertiary carbocation is more stabilized due to the presence of 3 alkyl group, that is the electron donating. Next is the Lucas test. That is very important test. I have already told you primary, secondary and tertiary alcohols are very important. So if you want to differentiate the primary, secondary and tertiary, we are using a Lucas test. In this Lucas reagent, it's on the name of chemist, and it's used the Lucas reagent. Which is the Lucas reagent? Zinc chloride and the hydrochloric acid. If we have to react the tertiary alcohol, immediately oily layer is formed. What happened? First of all, you can try to understand. This one is the tertiary alcohol in the presence of HCl and zinc chloride, that is called as the Lucas reagents. tertiary alkyl halide is formed. Tertiary alkyl halide is formed, and when they both are reacted to each other, immediately it forms the oily layers. If there is present the secondary alcohol, it in the presence of HCl and zinc chloride, then oily layer forms in 5 to 10 minutes. And if there is a primary alcohol, it forms oily layers. Of course it forms the oily layer, but only on the heating, not in the cold condition. This is the difference. How do you differentiate between the tertiary, primary and secondary alcohol? By the Lucas test. This is very easy test. If you react the tertiary alcohol with the Lucas reagent, it immediately forms the oily layer. If secondary alcohol reacts with the Lucas reagent, it forms oily layer, but after the 5 to 10 minutes. But if there is a primary alcohol and reacts it with the Lucas reagent, then what happened to it? It needs heating, not taking place in the cold region. So this is the test. This is called as the Lucas test. Why is it happened? What is the reason? I have already told you, because this is the tertiary alcohol. It contains the 3 alkyl group. When the OH is removed with this hydrogen, carbocation is formed. Carbon C. Here is a C with the 3 alkyl group. C. OH is removed with H, forms the water. Carbocation is formed. Which one carbon? C carries the, it becomes the, by the removal of OH, it becomes the electron deficient. So it is called as the carbocation. And here, because 3 alkyl group is present, so we can say tertiary carbocation. That is very stable. As it formed tertiary carbocation, the 3 alkyl group, which is electron donating, and it shifts its electron to the carbon positive, and it becomes the more stabilized, because the positive of the carbon is stabilized by the electron donating of the 3 group. So tertiary is more stabilized and forms as soon as possible. But if there are 2 alkyl group is present, so it also tries to satisfy the carbocation positive, but not as tertiary. The third one is the primary. It contains only the 1 alkyl group, which is trying to stabilize this carbon with a positive charge. So this is the reason tertiary carbocation is more stabilized than secondary. Secondary is more stabilized than the primary. As a result of this, Lucas test shows. Next is also very important. What is this? This is called the Idoform test. If there is a methanol and ethanol, and you want to differentiate between the either ethanol is present and the methanol is present, we have to react. We are going Idoform test in the lab. Yellow crystals of idoforms are formed. How is it reacted? For example, ethyl alcohol reacts with the iodine crystals and in the presence of sodium hydroxide. What happened? A CHI3 is formed. These are the byproducts, but here is CHI3 is formed. That is called as the yellow crystal of this formed, and this is called as the Idoform CHI3. And this test is only possible with the ethanol, and methanol doesn't give this test. So this Idoform is used for the identification of ethanol, right?